Hello and welcome to another video at Indies Tech. Today's video is on MATLAB image processing tutorials. I have made some previous videos, so in this video I have incorporated those videos for ease of access. Now, the start of this video I gave a brief background of MATLAB, what it is used for, and its creation. The whole background then incorporated with the topic. Following topic has been discussed. MATLAB tutorial for beginners, then image color channel separation, edge detection, signal to noise ratio, histogram equalization with Excel and MATLAB, Raspberry Pi 4 night vision project with MATLAB, then camera object tracking with MATLAB, and lastly VRAP smart robot simulation with Raspberry Pi and MATLAB software. All of them are image processing topics with lots of tips and tricks and techniques. The uses of MATLAB are the following: numerical computation, data analysis, visualization with algorithm developments, engineering and scientific application, in the field of education, integration with other programming language, industry and research, product development. Clive Moore, American scientist and academic, invented MATLAB back in 1960s during his PhD thesis, and on the left is the headquarters of MATLAB in United States. The computational requirement for MATLABs are the following. Processor, it is recommended to get 4 core plus. 16 GB RAM is recommended, but all of my project has been done in 8 GB RAM. 20 to 30 GB disk space is recommended. Graphics should be OpenGL 4.5 plus with SSD storage. Now this table gives the operating system a specific background of the computational requirement for MATLAB. So as you can see, these are all same and there is not much different from the previous slide. The prices of MATLAB is for individual license is 800 GBP per year. The price of MATLAB for a standard license, it costs you £800 per year. Then it starts, the most expensive one is the startup version of it, which is £3,250 here in United Kingdom. Academic versions are £228, but the license can be shared with the student free of charge, whereas the student version itself costs only 59 GBP, but it can be a free trial version free of charge for less than a month. The home edition can cost £105. The best place to learn MATLAB is not from my video or from YouTube. The best place to learn for any technical topic is from the manufacturer's website. Here in MATLAB help section you will get the detailed description of all the libraries, but of course the YouTube videos or the technical help from other sources can be helpful. Now, without further ado, let's get started with the tutorial. Just to be sure, Next, the tutorial will be on following topic with the, I will start from next the tutorial. Next, the tutorial will be on following topic. I will start with beginner level project, then slowly progress to more technical like edge detection, RGB edge detection, image color channel separation, noise removal, image signal to noise ratio. Then we'll progress on histogram equalization and contrast stretching with image histogram equalization with Excel and MATLAB, then 3 of the Raspberry Pi 4 project. The last one is on VRAP robot simulation with OpenCV and MATLAB. Now let's get started. Hello, welcome to another video of Indis Education. In this video, I will discuss MATLAB basic image processing techniques, including opening an image file in MATLAB, converting to grayscale image, separate the image RGB color components. Now let's discuss how computer vision works. Human can understand the semantic meaning of an image. On the other hand, computer see only digital representation of an image, i.e. by looking at a cat image, human mind process the vision data as a cat. But for the same image, computer only see pixels in simple explanation 0 and 1. In this background image, human sees the reflected lights and process the information as a canal and footpath. On the other hand, computer sees the different intensity pixels segmentations laying in different ways. Now let's get familiarized with the MATLAB work window. There are 3 parts we mainly need to concern of. The first one is the current folder. Here you can see I marked it on the right, the current folder, then the command window, and then the workspace. When you first open any MATLAB the software, you see these 3 windows. So the current folder is the which folder we will be working on, and the command window is where we test our codes. It's basically is like a rough notebook, but whenever we implement any script, it goes through the command window, and whatever goes through the command window, either it is an input or output, it is always assigned at the workspace. The workspace is on the right, so the x and y in this variable. Now in our code, to assign the current folder, we can use this line of code. So if we just write pwd current folder, which will show that which current folder we currently have, then so just try it. If I run this code, it goes through the command window, the same bigger command window I showed you previously. In this time I have opened the script actually. So the command window is showing that current folder is C, the tutorial, and the MATLAB first image tutorial. We can change the file path, whatever we will be working on. These 2 lines of code I just commented. If we just take out of the comment and implement it, basically I wrote the same file path, whatever is currently assigned on. So if I run the code, it changed the whatever the current file path it was, then it shows the new current path with the current folder and pwd. Now how to open the first script? If we can just see the window, if we can just click new, then click the script. There are a few kind of script. One is script, the normal script, and one is the live script. At first, in this stage, I would recommend to use the normal script, the one at the top. So if you click the script, here you go. It just came with the previous window I have just shown previously. So in this window, if you write the code, your first code would be B equal 3, C equal A plus B. So this is a simple line of code, and if we run this code, it shows in the command window the C equal 5. So A we defined it. A is a variable, A equal 2, B equal 3, and C equal A plus B. Now this part of the code, I will open a pre-made file just to keep things in short. So this file is located on the same folder path I have provided. So this is the image processing fast tutorial MLX. If you can just click this file, it will open up itself with the whole script of codes. So this is the definition. So this is the letter I define the whole code. I define in a variable. So when you say what is a variable equal I am read this file path actually indicating this image llama.png. Llama.png is here. So I am read the full file path. It's located in user desktop MATLAB fast image tutorial llama.png. I assign a title. This is the code for title. So for the any image, we just need to write title. This word can't be changed. But this is the image. This is the name. You can assign any name you wish. So this is the full image name. If you can just if we edit this thing, we take the E off. As you can see, if I run this code, so the now the next part is converting the image to grayscale. The command for this is RGB to gray. This word can't be changed, but these are the variables. You can write any name you wish. The A indicate the first picture, first image. So this is the variable. We define the whole thing as A. So this is color image, RGB image, and converting to grayscale. So A grayscale from RGB. Then this code I am sure B. So this is the result of grayscale conversion. Now the next part is separating the image in red, green and blue color component. So the first code is the C variable equal A. A is the main image, main color image. This is the A main color image. We're converting to red. That is the code for red conversion. So we wrote like 1. If we make it 2, means green, and 3 is blue. Then I am sure C. So the red component, red color component conversion is showing here. So this is red component of llama image. As I have already included the color patch here, this patch, as you can see in the main image, it has got the red component, green component and blue component. When the color separation happen, if it is only red, so the red will light on, it will be white and other will be black. So we can see in the red color conversion, it has light up and the other two color has been marked as black. Whereas in the grayscale image, there are some intensity, different intensity level, the color is there. Now the green color component conversion happened here. So the green is on and 2 is dark. The code is that. This is the same code as we used in previous line as this code, but we wrote here instead of 1, we wrote 2. Now in this part we have done the blue color conversion. So this is the same line code as we wrote previously. So just instead of 2, it's 3. Remember 3 is blue, 2 is green, 1 is red. Now we have converted the whole image to binary image. Binary image is just 0 and 1. With this command, there is a threshold implementation. If the color goes beyond that threshold, it convert to 1, which is black, and if it is below the threshold, it becomes 0. So this is 0 and 1 only. In this level, this image pixel has got nothing to do with the color image. It has got pure black and white, which is 0 and 1. Now this command figure subplotting all the images we have created earlier in one image. With this code, this numbers 3 means the row of the figure, 2 is the column, and 1 is the index number. So for the first image is 3 row 2 column, where the image will be in index 1. So it is index 1. The second image is the grayscale image. It will be index 2. Third image, the red image, is index 3. Then index 4 is the green image, and index 5 is the blue image. Now if we can just try some other files I have already included. If we can just change the name llama png to this file rb.jpg, just write rb. If we can run the code, rb.jpg. So jpg, we can run this code. The same code format shows like this. So this is the main image with we open the same file, same code. We open the file with the same code and red, green and blue color component, then the grayscale image, then the red component of the image with this code, then the blue component, green component of the image with the number 2, and this number 3 with the blue component of the image. Now the whole thing in binaries, it shows like this because there was no white color. It was pure color, red, green, and blue. So the thresholding happened to be chosen for everything 1. It is more than the threshold assigned. Then in the same figure command, we can see the images like this. Now next bit, we try another image. So if we can just change the name RB, we need to assign this this image name, which is mji.png. This image we need to assign, so it will be mji.png. If we run the code, so we see the code, the red color component, the green color component, and blue color component. Bear in mind that these components are not pure red. There is always some noise in it. How it goes with our code: this is the grayscale, this is the red component, remember, with 1. This is the blue component with 2, and this is the blue component with 3, and this is 2 for the green component. And the binary image looks like this because you can see that there is some pure white and there is not very pure black, because there was some noise present in our image file. It was never pure black or pure white, as you can see from the main image. It was never pure black or pure white. So the binary conversion happened to be like this, and then we show the whole conversion process in one figure. Thank you for watching.
Hello and welcome to another presentation of NGS Education. In this presentation, I'm going to talk about different MATLAB operational parameters which you really need to be careful. It can hold you back at the beginning. So the first thing is that you check the version, which version of MATLAB you are using, and you document it properly, you memorize it properly. The reason is because if you go to another computer and if you use the different version of software to open the advanced version software, it would not work. For instance, currently if you're working in 2019 version software and if you go to another computer and try to open that file you generated with 2019 version, this file would not work. So make sure you check which version of MATLAB software you are using. So the best way to check is the top right, top left corner of the window. You see the version. Usually it is assigned as R20. If it is a 2019 version, it would be R2019A or 19B. If it is 2018 version, it would say R2018A or B. Same goes as the year goes. So for the 2015 version, it will be R2015A. So be careful about this. The next thing I'm going to talk about check the working directory. The program need to know from where the file are sourced. So there is a default file location, as you can see on the image, is in C program data memory in MATLAB programming directory, but you need to assign it which directory you really want to be. For instance, in this file, if you download the link provided and try to execute the code, you're basically trying to open an image file, but the image file is located in some different places. So if the image file is located in different places and you're trying to open that file which is not located where your program knows where it is, it would not work. So make sure you give the right file path. Now the next important thing is that you don't write your code in the command window. You know, at the bottom of the MATLAB window there is command window. So this place is basically is the rough notebook. This is for your practice. You practice your code. 2 plus 2 equal 4. You practice this kind of thing which you think is might work, so you just practice it there before writing it to the proper place. So this is called command window. So the command window, this is not for storing any code. It has no write your code in the editor window. You can see the editor window on your screen. Editor window is basically is the place where you should write your. Here you can see on the image, I basically opened the editor window. Once I have downloaded my file from the link provided, the file is in GIF format. So basically you download the file from the link provided, then you extract the file. When you extract the file, you open the file, and you on the top of the file path you click it and copy the file path. When you copy the file path, you come back to the MATLAB window. You come back at the MATLAB window and paste that file path, so the program would know from where it should look for the executable files. If you want to open an image, so the image content on that file, so MATLAB know where to look at, it will open that image. If you put the wrong file path, the MATLAB file would not find the file try to open, then it could not open anything, so it would give an error. Find the file. The next thing is you should keep the patience, because you know the MATLAB is a very high level language which takes time for the code to execute. So in this code, if you see, it's just opening a simple image. If you want to open this code and if you press the run button to come to this point, it takes about 7 seconds. So you appreciate that it takes 7 seconds. And finally, viewers, as you can see, I'm new at YouTube and I need your help. So if you like this video, please like and share and subscribe. That would help me to achieve my goal. Thank you very much. Thanks for watching. Hello and welcome to another tutorials of Indies Education. In this tutorial, I'm going to discuss MATLAB age detection algorithms. Now let's do some recap from last week. I discussed previously about few fundamental things which is really important for the beginners to practice. If you can avoid these mistakes, you can really short your learning curve and move forward. So the first one is check the version of MATLAB you are using. Like my one, I'm using MATLAB 2019. So this file you can download from the link provided, will not work in 2018 version. The next one is know where your file is located, so make sure you put the right file path on the working directory. The third one is don't write your code in command window, and the fourth one is write your code in program editor. And the fifth one is be patient. MATLAB is not a very fast language, so it takes time for the code to be executed. Okay, let's open a new file. New scripts, live script. I'm going to open the live script. When you open the live script, give it a name. So text, heading, title. Now let's start the code. So the code button, give it a variable name a equal open an image file. So the command is imread parenthesis apostrophe the name. So I'm going to open this image file yahoo.png. So top png semicolon. Now I will convert this image to grayscale image. The command is RGB to gray, RGB to gray. As you can see, it's been highlighting there, so just click it. So which file I want to convert to grayscale? This a variable. So a, which is the yahoo.png image assigned for, again semicolon. Now I want to open both the file in side by side so that I can compare. So subplot that will be in 1 row 2 column. So bracket 1 row 2 column, and the image number I want to get is the first one, so image number will be 1, comma imshow a, give it a title name, title color image, semicolon, then another image. I will just copy the whole line, copy, changing the variable. Everything is same, but this time I want the image to be the second one, so just changing to 2, and the variable is b, the grayscale image. B, title, changing the title grayscale. Grayscale image. Now let's run the code. Okay, you can see side by side my image is color image and grayscale image. So this is a figure, 1 row 2 column. That's how you would write. Now let's talk about the age detection. First, let's discuss what is. So if you go to Google, so if you go to Microsoft Edge, just write what is image age detection. So you get the Wikipedia page. So let's go to MATLAB. So the age detection is basically locating the boundaries of desired object in another fundamental aspect of image processing. So locating the boundary of the image age. So this is the image. This image shown here is a 120 by 120 pixel image. So it has got 120 column and 120 rows. The age is detected. Basically the boundary of the image has been detected. Now how are you gonna apply this boundary? I would write IM tool B So just run the section of the code. Here I can see my image. Now in this image, if you hover your cursor, you see the image is 255 by 255 8-bit image. It has got 255 rows and 255 column. So as you can hover your cursor, you can see here is a block. So the block, it has got the pixel number is showing, it is 63 row and 30 column pixel, and it is 0. This one, as you can see, this is 155 row and 18 column pixel. No, basically this is 155 column, 18 row pixel. This one you can see is 47 column and 26 row pixel. Again, the pixel value is 0. How about the white one? Here, if you put the Y button, which is white color, you can see the pixel number is 80 column, 109 row pixel, and the pixel value is 255. So the white is 255 and black is 0. So this is the pixel value. So we need to change the edge will be detected, the change in boundaries. So the boundary change happen here, this circle button, the boundary change here, the boundary change happen in the Y, the boundary change, different boundary change happen here. So what is the difference between the white color Y and this smiley emoji button? You can see the pixel number is 122 edge column and 149 row. The pixel value is 232. You can see it properly. The pixel value is 232. As you can go to the eye of the smiley face, if you can hover here, so it is black, but as it is not proper black, so the pixel value is 97. In this way, so basically the program in the background, the following edge detection command I will be using, they will be changing, they will be detecting this change in the pixel value, and they will visualize it. So let's go back to our code. So there are different kind of edge detection. First I will use the Sobel edge detection. So Sobel, I'll go the variable name I give is C equal edge bracket B comma apostrophe. The name of the command is, as you can see, there are different Sobel, pre-wit, Robert, log, zero cross, Kenny. So basically you write any of the name. These are the main edge detection technique. So I write, let's write the Sobel, this name Sobel, S-O-B-E-L, capital S. Semicolon. Now let's open the whole thing in one figure with the black and white and grayscale. So the change it to 1 row 3 column. So 1 row 3 column. Copy this line, so change to column number 3. Our edge detected image will be located. So the column number 3 this time is C C, title, Sobel image. Let's run the code. Here you can see the three image has been published side by side. So the color image, grayscale image, Sobel image. In Sobel image, so the age is detected, is basically detected the change in the pixel values. So from here the black pixel value, which previously we have seen is 0, and different pixel value is more than 0, close to 255. As this place is not proper, is there is little bit white, I would assume it would be 100 or something, what value it is. So if I take the IM tool, so this is the picture. So if I go here, is the white 255, 97. This pixel here is 216. This pixel little bit black is 102. So that's how the age is detected, and the command I have already shown you. Now let's go a little bit further. What actually happened background of this code generation? You can go back and we can, if we just search it online, if we just search the Sobel age detection, go there, as you can see, what really happened at the background is that there are two kinds of Sobel edge detection. One is horizontal edge detection and one is vertical edge detection. What basically they do is that, for instance, think about this image pixel as the A1, this pixel here, the image has been shown here, which I think is a Vietnam War picture. So this pixel number M go to the center point of the kernel, and this top left get multiplied by this number -1, middle left is multiplied by -2, and the bottom left is multiplied by -1. Same goes for the top right, multiply top right, this pixel is multiplied by 1, this pixel is multiplied by 2, and this pixel is multiplied by 1 again. The middle is multiplied by 0, and this process is carried out to all the pixels, all these pixels. How about when the center pixel is there? So this is center pixel, this value here is out of the image, so it is considered as 0. So if it goes out of the frame, it is considered as 0. So there are two kind of multiplication went through two kernel. One is horizontal kernel matrix, one is vertical kernel matrix, and that give us this code. Now let's try another edge detection technique. So basically just copy this line of code, change the name to D, same goes the age, detecting the age of the B, the grayscale image, just changing the name, pre-width, I get the name from the list, so this is the pre-width. Pre-width edge detection. So here I would just change the value to one row 4 column, my pixel will be 4, changing all this, 1 row 4 column, 1 row 4 column, 1 row 4 column. If I run it now, changing the name, I'm sure D, preview it image. Let's run it. So as you can see, I've got my 4 picture side by side. So this is preview image, Sobol image, grayscale image, color image. Let's just see one image at a time. So I will just say I am sure D is the preview image. I'm sure D. Let's run the code. Let's deactivate all the lines at the top, so that way we can deactivate all the lines. Just leave these lines, select all the lines which we want to deactivate, right click, put command button. The code will consider this line as comment, not code. This line need to be deactivated as well. This way of commenting is quite effective because you can use it for debugging to fault finding. You can use it for fault finding in the code. So if I just run the code now, here is my preview edge detection. If I deactivate this line, comment, and no, let's keep it here. I want to show the Kenny edge detection. I want to show the Sobol edge detection we have carried out previously, but in the array format where all the image was shown in one figure. So this time I am sure C. So this is the Kenny edge detection. Now I want to compare between Sobol and preview. So I'll do a subplot, copy, paste, subplot, one row, 2 column. Number 1, I want to show the Sobol image. C is the Sobol image as we previously assigned it. Title, Sobol image. The next one as it is, subplot, paste, just changing the number of the column. So number 2, preview image. If I just run it now, let's deactivate this line as well. So comment it. If we just run it now, well, this one need to be changed to so as you can see, this is my Sobel edge detection, this is my pre-weight edge detection. Again, what is pre-weight edge detection? Pre-weight edge detection can be found, just Google it. Pre-weight edge detection image. So the pre-weight goes same like the Sobel, but the kernel is different, the multiplication matrix is different. So this is the multiplication matrix or mask. So this is the horizontal mask, this is the vertical mask. So the horizontal mask is, as you can see, this website. Let's click it. So edge detection. So basically the pixel value is multiplied. So if I open my image, so think about this pixel value, which is the pixel at the left or top left corner. The pixel number is pixel location is 29 in x direction and 23 in y direction, x direction, y direction, 18, 34, 27, and the pixel value is 0. So if you multiply the 0 pixel, so the 0 will be the center one, and all of the neighboring pixel will be multiplied by the following numbers, following pixels. How about the white one? The white one is pixel number 93x 122y. The pixel number is 255. So this pixel will be multiplied by 255 times 0, and the neighboring pixel, which is 110, will be multiplied by this 0. How about the left side pixel? Left side pixel, consider this pixel value is 96, will be multiplied by 0. How about the top pixel? The top pixel is 185, will be multiplied by -1. Top center pixel 180 multiplied by -1. So this way the Sobel, this way the pre-weight edge detection is generated in MATLAB code. Again, all these things happen at the background. We just write the name and the program would do it. So let's open another edge detection line. We give another variable e equal edge bracket b, the grayscale image we have already assigned RGB to gray. So the b, I want to open it as canny edge detection. So b comma apostrophe c a double n y canny edge detection semicolon. This time let's just open this canny edge detection picture first, then we will compare it. So if we just copy it, copy and paste, changing the name, comment all this, comment, deactivating all this, run. So this is my canny edge detection. Let's compare 3 edge detection, Sobel, pre-weight and canny at same figure. So again we will do subplot. Let's deactivate this line. but it will change because I have got 3 image, but in this configuration only possible to show 2 image because it has got 1 row 2 column. So how about we increase 1 column 3 column, copy this code. As you can see, I'm trying to copy and paste the code I have already created. The reason behind is that I want to make you a habit of modular programming, where you make one module, then you reuse this module to make another line of code. So this time is column 3. The variable is not D, it is E, this variable. E, title Kenny image, change the title, Kenny image. So if I run the code now, basically it will show 3 age detection image in one figure. Let's deactivate this because I don't want to show this image this time, so just comment it. If I run it now, so I've got 3 images side by side. As you can see, there are subtle change in different edge detection techniques. For instance, in pre-weight edge detection, you can see it has detected the least amount of edges, and the Kenny edge detection has detected the most amount of edges, and Sobel is in between. There is a difference between these two, Sobel image edge detection and pre-weight image edge detection, and the Kenny. Kenny is different than these two because Kenny's masking work into some Kenny's masking work little bit different way. Kenny edge detection technique differ from the first two. The way is, if you can just Google it. So these are the processes. You can see the Kenny edge detection happen rather than the one-time kernel implementation, like a vertical kernel and horizontal kernel implementation. It goes through few of these steps. First, start with smoothing with Gaussian filter, then gradient calculation, non-maxima suppression, and thresholding. I'll take a break. I will close this tutorial today, and the next tutorial I will discuss more about Kenny edge detection and all these processes. Thank you for watching this video. See you next time.